Okay, so in this example, we're going to be solving a circuit with a supernode. If you'll remember, a supernode is two nodes that are connected by a voltage source that you can pretty much treat as just one big node. What that means practically is that all the currents exiting this big supernode, you can still put them all in one equation. It's like I1 plus I2 plus I3 plus I4, I5, I6. They'd still all equal 0. And if you had a branch, say, like this, going between those two nodes, you can just ignore that altogether, because you'd have no currents entering or exiting the greater supernode. It's just going from one node to another node within the same supernode, so you can ignore that. Okay, so in this circuit example, you can see we have a supernode right here. Again, that is two nodes directly connected by a voltage source. So when we go to solve this, we're going to draw all our currents like this, exiting, got Ix over here, and that is all of them. So when we're writing the equation for this supernode, we need to label them first. So I'll say I2, I3, I4. We can just set all these to 0. Since we want to go ahead and use the node voltage analysis method, I am going to set this to ground, and this will be our third extraordinary node. So we'll call this V1, this V2, this V3, and let's go ahead and write our KCL equation for V3. So we have, we'll say, I5, I6, I7, I5 plus I6 plus I7 equals to 0. So now we want to convert these currents into voltages and resistances. So let's start with I1. This can simply be written as minus 2 amps because we have this current source here that is going in the opposite direction of I1. So we have minus 2. Then for I2, that is the voltage drop from V1 to ground. So V1 minus 0. We can just write that as V1 divided by 0.5, because that is our resistance. Then on this side, we have I3. I3 is the voltage drop from V2 to V3 divided by 0.5. So we have V2 minus V3 divided by 0.5. And finally, I4. I4 is the voltage drop from V2 to ground divided by 0.5. All this equals to 0. Now let's do the same for our second equation. We have I5 right here, which is the voltage drop from V3 to V2 we have I6, which is going in the opposite direction of a 4 amp current source, and I7, which is going in the same direction as a 2 amp current source. And now we're going to solve our system of, oh, not yet. There's one more thing we need. You'll see we have 1, 2, 3 variables, only 2 equations. We need one more. That's where the supernode comes in. As you'll know, a voltage source, ideal voltage source, raises the voltage by the, rating that it's rated for. So we know that V2 is equal to V1 plus 6. So you're starting at V1 and you're raising the voltage 6 volts to get to V2. So V2 is equal to V1 plus 6. Okay, so let's solve the system. I like using matrices, so that's what I'm going to do. Let's get the first equation down here. And get V1. Let's see, we have divided by 0.5, which is the same as 2. And that's all our V1 terms for the first equation. And then plus V2 is divided by 0.5, divided by 0.5, 2 plus 2, V3 minus divided by 0.5, negative 2. All that is equal to, we're going to get a constant to the other side, so that's going to be 2. Our second equation, doing the same thing. V1, there are no V1s here, so that's going to be a 0. V2 is negative divided by 0.5. And V3 is positive divided by 0.5. We're going to bring our constants to the other side. Plus 4 minus 2, that's another positive 2. Then our final equation, if we bring V1 to the other side, we have V1 negative 1 plus V2 just 1, and all that is equal to 6. So now I'm going to whip out my TI-84, go to matrices, going to edit. We have 3 equations, 3 variables, and a constant. So let's just put all these numbers in. And 0, V3 on the last one. Alrighty. I'm going to go to math. Our ref is reduced row echelon form. Here we go. V1 is equal to negative 2. V2 is equal to 4. And V3 is equal to 5. This is actually more information than we needed, because all we're doing is solving for Ix up here. So let's bring these up to where we need them. And we will see that Ix is equal to the voltage drop across this resistor, which is V2 minus 0, so V2 divided by the resistance. So that's 2 V2 equal to, what is this, 4. So we have 8 amps. Box our answer. and we're good to go.